Okay. Okay, we have discussed about force, column force. Yeah. It described the interaction between at least two charges, electric charges. Yeah. So force is a vector quantity. In this case, column force means that the interaction between two charges with distance between them. Okay, so yesterday, for example, we described the interaction between Q1 and Q2. Each of its positional vector is R1 and R2. Okay, and the difference between them is R2 minus R1. Okay, so first we consider F21. F21 means, F21 means that the force acts on Q2 caused by Q1. Yeah. So that's basically the force act on Q2. Okay. For F12, it's in the other side. I mean, this force, the force. So 1, 2 means the force act on Q1 caused by Q2. Okay, so if we insert the data, for example, for this example, we have Q1, this is one column, and Q2 is minus 2 column. So what we have here is that which one is the definition? So this is the definition of F21. Okay, and F12 is the other side. We have F12. This is the same, Q1, Q2 over. So this is R2 minus R1. So F21. So F12 means that R1 minus R2 to the 3, and then we have this one. Okay. If you insert the data, if you insert the data, then we'll get sorry, which one is the leader of the class? The coordinator of the class, sorry. I forgot the name.
Yes, sir.
Can you tell the others who is late for Zoom the reason why they are late? Just sending, yeah, just sending the picture or the reason to MS Teams. Yeah, I will read.
Okay, so
or her message. Then I decide whether he could or she or he could attend this class.
For those who are late.
Yeah, right? Only for those who are late. It's already above 5 minutes.
Oh, okay.
Okay.
Yes, sir.
Yeah. Okay, we have this 9 times 10 to the 9, 1 minus 2 over this is the same, yeah. 4 plus 4, 3 over 2, and then R1 minus R2, R1 minus R2, sorry, R1 minus R2, so this is 0 minus 2i plus 2 minus j, 2 minus 0, j, right? Okay, here we have 9 times minus 2 over square root 8, 3, and this is minus 2i plus j. Okay, yeah. And then this is Newton. And then we get, this is 4, this is 36 times 10, 8 to the 3. And then this is I minus j Newton, right? So in this case, this I is positive and G components, Y component is negative. So the direction of which one? Okay. So this is the direction of F21 is like this. So F12, which act on Q1, is F12. If you see that the magnitude of F12 is equal to F21. Okay, but the direction is opposites, right? The direction of these two forces are opposite each other. Okay, So it means that the sum of F, the vector F1, 2 plus F2, 1 is equal to 0. So it means that F2 is minus F21. So this force act on Q1 and this force acts on Q2. Yeah. They have the force acts on different charges. Okay, so this is the third law of Newton's third law of motion. Newton's third law of motion. Sorry. So this the strong condition. Yeah. What is mean strong condition? It means that the force, the action and reaction. This is, for example, action. This is reactions. They lie on the same line like this. So this force F12 and F21, they coincide on the same straight line, okay, but the opposite direction. So that's why we call it, this is a strong condition. Is there any question about these materials? Any questions? Any question?
Sir, can I ask a question?
Sorry, no question.
Can I ask a question?
Yes.
Oh, I sort of missed the problem question. If you can go back to it.
Which one?
What's the question? Oh, what's the problem? I mean, or is this just an example?
The problem. This one? Or this one? Or this one?
Is this just random numbers plugged in, or are you basing it off a problem?
I don't hear you clearly. Can you speak more louder and clearly?
Is this from a example problem, or is it just random numbers?
Random numbers. What do you mean by random?
Oh, I mean, you're just giving an example.
Yeah, I just give it an example. The big question is that the sign of the charts also influence the direction of the force.
All right. Thank you, sir.
Yes, okay. That's the goal that I give this example. I mean, you have to see that the charge also influence in the direction of the force acting on it. So if the question, for example, if you have an exam, so the problem you ask to write down or to determine the force, you have, so the efficient way to do that, you just directly, for example, if the problem asks you about to determine the force between two charges, for example, so you just directly just insert everything, the data here. For example, I give it to you directly to this formulation, to this force, column force formula, and then you get directly exactly have sorry. So you just finally get everything. I mean, the magnitude of this force and also the direction of the force. So it's more efficient if the problem that you ask for is determine the force. But if the problem is you have to determine or calculate, compute, for example, the magnitude of the force, then you have make the magnitude. I mean, you have to write down the magnitude. So the magnitude of this force, for example, is positive. Yeah, the magnitude is always positive. The magnitude of this one is 36 times over 8. Yeah. Newtons. And the direction, usually the direction, this one, you just write like this. This is I minus J, sorry, 2, 1, sorry, this plus minus, sorry. If you write, for example, the unit vector, you just write like this. R2 minus R1 over, sorry, this would be, sorry. This R21 over R21. So this is minus 5. The magnitude of R2. Sorry, this is square 2. Yeah. Okay. Yeah. And for the other side, for F12, you just so for R12, this is on the minus of R12. Okay. And also this is also the minus of R12. Okay. Okay, that's for Coulomb's law, for two charges. We will make it clearer if we talk about the problems, for example, for 3 charges, etc. But it will be discussed maybe in the tutorial on Friday, but not this Friday. I think I don't receive yet the tutorial module. So this Friday maybe we don't have this lecture this Friday. Maybe next Friday, maybe next week. Yeah, next week, not this week, not Friday this week. Okay, let us start with new new material today. Okay, about electric fields. Electric field. So what we have, this F, for example, yeah, we have force equals to K Q big Q little q over R squared, this unit vector. Yeah. So the electric field define as E. So let's say this is called test charge, and this is source charge. Source charge. So the electric fields define F over a test charge, little q. Okay, this will get K big Q R squared over this one. So what does it mean that just 1 second. So what does it mean that, for example, we have these coordinate systems. This is y axis, this is x, and the q here, the big Q here lies on the origin. Oops. This is q, okay, and this is r. This is, for example, the point P, for example, where the point P is related to what we want to know about this electric field here at the point P. Yeah. So this is called this field coordinates. Okay. So in general, if we, for example, have a charge, this is x, y, this is O, but the Q here, for example, you take anywhere. Sorry. This is R prime, let's say, and this is P, for example, a point P. Yeah, this is R. Okay, this R prime means that this is a source coordinates, and this R is field coordinates. So we want to know about the field on P, on the point P. Okay, so in this case, we have the difference, the factor difference between them. This one. Oops. This is R minus R prime. Okay, so the electric field on P, on the point P, is K. Sorry. K Q over R minus R prime to the 3 times this vector. Okay. So if the Q is positive, okay, if this is Q, the charge here, yes. So if the Q is positive, this will give us the direction of the electric fields. It's outward, yeah, like this. This is for Q positive. If the force is negative, will be inward, yeah, the direction. It means that the vectors to the not this one, sorry. So this is P, so this is, this is outward like this. For Q is positive, if negative, this is inward. Q less than 0. Okay. So it means that for Q, if Q is positive, then we have an outward field line of the inward line of the electric field. Yeah. Sorry, outward, not outward. The outward line of the electric field. This is Q. And then if you have Q less than 0, this is Q here, and the line of the force or the line of electric fields is inward, yeah, to the charge. Okay. Oh yes, before I forgot something. So there is a remark, yeah. Let's say a remark about Coulomb's law. So if R equals to 0, then F, let's say not equal, is indefinite. Let's say goes to 0. If R goes to 0, then F will be blows up, diverges, or blows up. F blows up. So it means that Coulomb's law does not recognize self-interaction. So in classical physics, there is no self-interactions. So interactions mean we have two objects, at least two objects, interactions. The Coulomb laws, at least, and also maximal, two charges. Okay, three charges, okay, but we can divide it by three interactions between 1 and 2, 2 and 3, 3 and 1. That's three interactions. So at least we have interaction at least two charges. Okay. But if, for example, the test charge is coincides with the source charge, that I mean that this is the self-interaction. So in classical physics, there is no self-interactions. That is exceptional, that is excluded in quantum case. In quantum mechanics, you have self-interactions, but not in classical physics. Okay, that's the remark or some some remarks. Yeah, a remark of the Coulomb's law. Any questions? Okay, what about if we have more than two, for example, two source charges, two force charges, sorry, two electrical charges. Sultan Sulaiman. Sultan Sulaiman is already in this class. I mean, is there any connection problem or Sultan Sulaiman? Okay, let's get back to this one, two electric charges.
Sir, sorry to
Yes.
interrupt, but Sultan said he's in the waiting room.
Sorry?
He's in the waiting room, Sultan.
No, why he's in the waiting room? I mean, is he have a problem with connections?
Okay, wait.
Okay. Let's say Q1 and Q2. Okay. Let's say this is origin. This is Q1 and this is Q2. Okay. And this is their position. Its position. R1, this is R2 prime, okay. So let's say, for example, this is P. And this is R. Yeah. And then this E here is the sum of the electric field from Q1 and then the electric field from Q2. Okay, and each of them has the form K Q1 over R minus R1 prime over 3 R minus R1 prime plus K Q2 over R minus R2 prime minus R1. Okay. So So this is the superposition. Superposition. Of electric field. What about if we have many charges? Many charges. Let's say Q1, Q2, dot until Q, the big N. Then the electric field, the total electric field, let's say total is Q1, or let's say A1 plus E2 dot plus En, the big N. So this is from Q1, Q2, and this is from Qn. So usually this is symbolized, we could simplify the symbol, the statement, by using sigma, this. And okay, and this is equals to K over I and Qi minus I prime over 3. Yeah. Okay, that's general for many charges, the total electric fields of n charges and system. Is there any questions? So in the nature, for example, in our universe, in the nature, which one is realistic? I mean, you know that there is also a discrete charges. It's a discrete charges. And also there is a continuous charges. Continuous. Charge. Which one in the nature? It's more physical. Discrete charges or continuous charges? What do you say?
Excuse me, sir.
Yes.
What does it mean by discrete charges?
Discrete charges mean that we have, yeah, let's say 1, 2, 3. It's a number, integer number. N is an integer number. 10 to the 10, 10 to the 100, 10 to the 1,000, 10 to the million. It's still discrete. Okay. So which one is more physical? Which one is physical? In this case, discrete charges or continuous charge? Ahmad Rishad, Tohir. Ahmad Rishad.
Hello, sir. Can you hear me?
Yeah. What do you say?
Can you repeat, sir?
Yeah. Which one is more physical?
The discrete one.
Discrete charges or continuous charges?
I think it's the discrete one.
Why?
Wait.
Wait a moment. Juzaki Bungas itu ada ya? Nama Juzaki Bungas.
Yeah, yes, sir.
Yes. You should change your ID by writing your student ID and the name.
Oh, sorry, sir. I haven't changed it since last time. Sorry, sir.
Okay. So which one, Ahmad Rishad ya? Tohir.
Yes, sir.
What is the reason? You say discrete. Why?
I don't know how to explain it, sir.
Okay. Jaski, tadi mana Jaski tadi? Jaski. Yeah, Juzaki.
Yeah, sir.
Yes. Which one is more physical? Discrete charges or continuous charge?
What do you mean by physical, sir? Like we can see it, or
It's realistic, more realistic. I mean,
I think discrete charges, sir.
why?
Because molecules have different charges. I think, like.
Okay. Yeah, that's good. Okay. So everything in the universe or in our nature, in the nature, everything is made of an elementary particle. For example, let's say if an elementary particle is an atom, then for example the table or the chair you sit is made of atoms. And between atoms there is a distance, okay? And that is discrete, even if we see as a continuous things, yeah, continuous things. So continuous charge, it's an approximation. If n is greater or tends to the infinity, so there are so many particles. Then this summation could be right in terms of integral. Integral is qi replaced by dq r minus r prime to 3r minus r prime. Okay, so in discrete, for example, you have discrete case. You have Q1 or Qi, and this is the position prime R, this is the origin, this is P, yeah. So this is the discrete case, the formulation like this. And if n goes to infinity, so in the case that we can approximate the computation by using integral, continuous case, yeah. So it means that this is infinitesimal infinitesimal charge, and they have position prime with respect to this origin. And then we have this R, this is P, okay. These field coordinates. So this is what it means to be continuous things. Any questions? Okay, example. Let's say two charges, Q1, 2 column, and then Q2 minus 4 column. Let's say it's 0. Just for this R prime 1 is 0, 4, R2. Let's say this one. Just for example, yeah. So this is Q2 here. This is 2, 4, just for example. And then determine, for example, determine field, the electric field. On a coordinate, for example, yeah, this is meter. What about it? Can you working on it maybe around 5 minutes, and then I will explain to you in 5 minutes. Yeah, 5 minutes. Yeah.
Sorry, sir.
Yes.
Is that 4 and 4? Is that 4
Yeah,
and
4 and 4
or 9 and 4?
4, 4.
All right, thank you.
Just for simplicity. 5 minutes. Yeah, just 5 minutes. I will get back to you. Not yet. Okay. I will upload the video on YouTube so you can rewatch. You can watch this video also. Any questions? Okay, so at the end, we will sum this n A1 plus A2, right? And this is this one, 9/8 I times 9/3/2 I to j times 10 to the 9. So Newton. So this is the total electric field.
Sir,
Yes.
I have a question.
Yes.
For E2, why didn't you write the negative sign?
So negative. Oh yeah. Sorry. I forgot. Yes. This one
Thank you,
also.
sir.
Any question or correction? Okay. So this is the effective and simple way. If the task was asking about the electric field. Yeah. So the electric field is a vector quantity. So you can directly write everything in the vector. So this is the correct answer. So, for example, in B, if, so this is the simplest thing, if I put a test charge, let's say little q for one column, yes. So what is, to determine on test charge. So this is simple way. So we have, on, I put the test charge on P. F is Q times A. Let's say E total E. This is total E. So we get, this is 9. 9 times 10 to the 9. 1/8 I minus Newton. Okay. Okay, what about, for example, if we have 3 charges? If we have 3 charges, this one. Example 2, 3 charges. Let's say Q1 equal to 1 column, Q2 2 column, Q3 minus 3 columns. The position is, let's say, is meter, yeah, meter. The task is A, determine force, determine the electric field, electric field on 8,8 meter. You work on this problem around 5 minutes again, yeah? All of you. Can you determine the electric field on 8,8 meter, the point P?
Sir.
Just another 5 minutes.
Excuse me, sir.
Yes?
Can we have extra 2 minutes?
Extra?
2 minutes, so 7 minutes.
Okay, let's say you work on 5 minutes, and then if most of you is not yet finished, not yet finished, then I will give you additional 2 minutes. Just let's say 5 minutes, and then I will ask if most of you are not still finished the problem. I will give you additional 2 minutes.
All right, sir. Thank you.
Oke, sejauh ini kita sudah bahas tentang medan listrik ya. Medan listrik itu awal mulanya kita definisikan dari hukum Coulomb, ya, hukum Coulomb tentang interaksi muatan yang seperti ini. Ya. Jadi definisinya itu adalah medan listrik itu didefinisikan seperti ini. Biasanya gaya yang bekerja pada muatan itu dibagi dengan muatan ujinya. Jadi gaya di sini itu bekerja pada muatan uji. Ya, yang ini. F di sini. Ya. Jadi bentuknya seperti ini. K itu konstanta Q besar per R kuadrat ke R topi. R topi di sini adalah vektor satuan ya. Unit vektor. Bahasa Inggrisnya. Oke, nah jadi kita di sini membagi dua koordinat. Kalau R prime itu biasanya kita sebut adalah koordinat sumber. Kemudian kalau R di sini itu adalah koordinat medan namanya. Jadi yang menunjukkan medan itu di mana itu adalah oleh R. Gitu. Nah, jadi rumusnya secara umum, kalau yang atas ini rumusnya ini adalah Q-nya itu adalah di titik asal atau origin, di O di sini yang rumus ini. Kalau yang ini secara umum ya, jadi artinya muatan sumber itu tidak harus di titik 0. Kalau di titik 0 Anda tinggal setting R prime-nya sama dengan 0. Nah, medan listrik ini itu arahnya itu ditentukan oleh tanda dari muatannya, jenis muatannya. Ya, the sign of the charge ya. Jadi kalau muatannya itu adalah positif, maka Anda lihat di sini garis-garis gaya listriknya atau garis-garis medan listriknya itu keluar menjauhi muatan yang saya sebut outward itu. Outward ya. Kemudian kalau dia itu negatif, garis-garis medan listriknya itu menuju muatannya yang kita sebut inward. Oke. Nah, jadi ini untuk satu muatan. Nah, bagaimana sekarang kalau ada dua muatan? Nah, dua muatan tinggal Anda tentukan aja masing-masing muatan ini kan dia ada koordinat sumbernya ya gitu ya. Nah, tinggal Anda masing-masing hitung untuk EQ1 berapa dengan EQ2 berapa, ini seperti ini. Gitu. Nah, jadi medan listrik totalnya itu nanti tinggal Anda jumlahkan saja untuk medan listrik dari masing-masing muatan seperti apa. Nah, ini adalah salah satu contoh bahwa medan listrik itu berlaku prinsip superposisi. Jadi kalau ada dua buah muatan atau lebih, maka di suatu titik ya di luar dari muatan itu semua itu merupakan jumlahan medan listriknya. Gitu ya. Nah, ini juga analog ya, sama ya. Jadi ketika muatan itu ada banyak, dua lebih gitu ya, itu tinggal dijumlahkan saja semuanya. E1, E2 sampai EN. Rumusnya itu seperti ini. Jadi adalah contoh sistem yang banyak muatan yang diskrit gitu. Nah, secara umum di alam, di nature ya, bahwa benda itu, things itu secara umum tuh dia diskrit. Kenapa? Karena benda itu dibentuk dari atom-atom dan tiap-tiap atom itu punya jarak. Itu yang membuat dia itu diskrit. Nah, tapi itu secara mikroskopik. Nah, itu tapi secara makroskopik, karena itu sangat banyak atomnya, Anda bayangkan satu tetes air itu bisa 10 pangkat berapa? Satu Avogadro, bilangan Avogadro. 6,02 kali 10 pangkat 23 ya, partikel ya. Jadi Anda bayangkan 10 pangkat 23 dibanding dengan jumlah manusia. Jumlah manusia itu berapa? 10 pangkat 9. Ordenya ya, miliaran. Gitu ya. Belum nyampe 10 pangkat 23. 10 pangkat 23 mungkin sudah padat bumi ini ya. Gitu. Jadi secara makroskopik karena benda itu sangat banyak sehingga bentuk diskrit ini itu bisa kita aproksimasi menjadi bentuk kontinu, benda kontinu. Nah, jadi benda kontinu itu adalah aproksimasi gitu dari benda diskrit di mana yang n-nya itu sangat banyak. Ini setahu saya yang disebut namanya jumlah Riemann ya. Kalau nanti Anda belajar kalkulus, mungkin semester ini ya, integral tertentu. Nah, jadi kalau dia itu kontinu, itu bisa kita tinjau seperti ini. Ini bendanya, ini ada dq. dq itu adalah muatan infinitesimal, artinya muatan yang sangat kecil yang kita ambil. Ya, koordinat sumbernya itu adalah r prime, sedangkan koordinatnya itu adalah r, gitu ya. Sehingga rumusnya jadi nanti seperti ini, integral seperti ini. Mungkin nanti akan kita ambil contoh untuk besok ya, untuk muatan kontinu seperti apa. Kemudian ini contoh-contoh untuk yang dua buah muatan, ya misalkan ini muatan Q1 dan 2 kolom, Q2 itu dalam minus 4 kolom, satunya itu di 0,4, duanya itu di 2,0 ya. Kita diminta menghitung di jaraknya 4,4 ya. Jarak apa istilahnya? Jadi ini adalah koordinat medannya 4,4. Ya. Nah, tekniknya kalau dia itu sistem dua partikel atau lebih, kita harus hitung dulu satu-satu supaya teliti kita ininya. Jadi ini adalah R kurangi R1 prime. R1 prime itu berapa? 0,4, sedangkan di P-nya 4,4. Jadi ini 4 kurang 0 kuadrat ditambah 4 kurang 4, 0 kan, dalam kurung pangkat 3/2. Dikali dengan vektornya. 4 kurang 0 I tambah 4 kurang 4 J. Ya. Jadi Q1 karena positif dia di sini. Q1 adalah 2. Jadi didapatkan rumusnya adalah 9/8 kali 10 pangkat 9 Newton per kolom. Jangan lupa vektor satuannya. Vektor satuannya jangan lupa. Dan juga satuannya juga jangan lupa. Itu S1 ya, lebih sederhana. Dan E2 itu agak lebih rumit ya. Karena R prime-nya itu dia di 2,0 ya. Ya di sumbu X, tapi di sini Q2. Jadi ini didapatkan bahwa kalau Anda masukkan datanya, ya R1 vektor R1 kurang vektor R kurangi vektor R2 prime itu adalah seperti ini, dapatnya 2I tambah 4J. Jadi kalau Anda keluarkan duanya itu didapat seperti ini hasil akhirnya. Untuk yang E2 di sini ada tanda minus. Kemudian dia dijumlahkan E1 tambah E2. Termasuk minusnya dimasukkan gitu ya. Jadi dapat gitu. Jadi ini totalnya adalah arahnya. Kemudian kalau saya letakkan muatan satu kolom sebagai muatan uji di titik 4,4, yaitu tinggal Anda kalikan saja Q-nya, muatan ujinya, dikali dengan electric field medan listrik totalnya. Didapatkan angkanya sama, cuma nanti satuannya berbeda ya. Kalau yang medan listrik ada Newton per kolom, kalau gaya itu tinggal dikalikan Q, maka di sini jadi N, jadi Newton saja. Seperti itu. Kemudian nah ini untuk yang tiga partikel ya, Anda bisa apa namanya hitung ya pakai cara yang sama dengan di dua partikel gitu ya. Jadi Anda menentukan medannya di titik 8,8. Oke, itu sampai situ ada pertanyaan nggak? Yang Anda kerjakan sekarang ini yang 3 partikel bisa dikumpulkan hari ini ya. Maksimum jam 1 bisa. Halo? Ya,
Coba.
jam 1 bisa ya, jadi nanti saya buat assignment jam 1 untuk pengerjaan ini. Anda tidak perlu pakai koma-komanya, kalau akar itu nanti dibentuknya seperti ini aja, kayak di E2 di sini. Yang ini 5 pangkat 3/2 gitu. Cukup seperti itu, nggak perlu pakai desimal segala macam, udah susah. Jadi kalau untuk akar itu cukup terus diakarkan saja. Kalau itu bilangnya rasional ya, bilangnya rasional seperti akar 5, akar 3, cukup ditulis itu aja. Ada pertanyaan nggak? Jam 1 bisa ya dikumpulkan ya? Maksimal 1 soal kan?
Bisa, Pak.
Oke.
Bisa, Pak.
Oke. Saya pikir
Pak,
itu aja ya, terima kasih.
I have a
Thank you
question,
for
Pak.
your attention. Okay, let us end.
Pak,
Ya.
can I
Ya,
ask a question?